Hi everyone, welcome back to my channel, and if you are new to my channel then please click the subscribe button and click the bell icon for any updates of my channel. So let's get started. So in the previous class we have talked about data structures. So data structures are nothing but a way of storing data in a very organized and efficient way, so the data can be accessed effectively and very efficiently. Alright, so in today's class we are going to discuss about arrays. So we will study what is array, what are why we need array, what are the different kinds of array, how the arrays are declared and how it is initialized, what are its advantages and what are its drawbacks. All we will be discussing in today's class. So I think you are very much familiar with the fundamental data types like integer, int, like float, int, float, double, int, float, double, char, etc. Right. So, how do we declare a variable? So, for example, we will declare a simple variable int a. Integer a is equal to some value 7. So this is nothing but initialization of a variable, right? So we should also know like how this value gets stored in the memory, right? So here the number 7 will not be stored in the computer's memory as it is. Why? Because computers understands only the binaries, that is zeros and ones. So it will be stored in the language which the computer understands, which is nothing but your zeros and ones, right? So here a is nothing but the name of the variable, right? So here in a, how we can see is variable is nothing but, you can say, like a container to store elements, right? Here the number 7 is going to be stored in a container named as an a, which is nothing but a variable, and it has a memory address associated with it. So we can take any value. Let me take it as 100. You can take 200, 300, any number of your choice, but for example I will take 100 here, right? So this is how the number 7 is going to store inside the memory. But let's go a little bit deeper than this. Okay, so as I have told you that this uh, computer can understand only binaries, that is zeros and ones, right? So this number 7 is going to be converted into binaries and then stored inside the computer's memory. So let's convert this 7 in binaries. I hope you know how to convert from decimal to binary. If you do not know, or if you want to know, then let me know in the comment section that you want to know, you want me to teach you or make a video on how to convert a decimal into any other uh, number formats, right? Number format conversion. If you want me to make a video on that, then please uh, please comment it on the comment section, right? So how do we convert this 7 into decimal, into a binaries, right? So we go on taking 2 to the power 0, 2 to the power 1, 2 to the power 2 to the power 2, 2 to the power 3, right? So 2 to the power 0 is nothing but 1, and 2 to the power 1 is nothing but 2, 2 to the power 2 is nothing but 4, 2 to the power 3 is nothing but 8, and so on, right? But here our number is 7, So we don't need to go any further than 8 because 8 is greater than 7, so we don't need a number greater than 7. So we will stop here. So whichever places where the total, when you sum it together, it should give you the number 7. The total should give you the number 7. So we cannot take 8 as 8 is greater than 7. So here the place which is not taken will be replaced with 0. Alright, but here we can take 4, right? We can take 4 plus 2 plus 1. Whole together it is nothing but your number decimal 7, right? So what all numbers we have chosen here? 4 is chosen, 2 is chosen, and 1 is also chosen. That's why all the numbers which you have chosen should be written as 1. That means here the place, in this place we will put 1, here also we will put another 1, and here also we will put another 1. This is nothing but the decimal equivalent of your number 7. I hope you can see. Check. Alright. Okay, so we have what? We have place where whichever the number which we have taken, I put it 1 1 1. This is nothing but your decimal 7, right? So this is how we convert from decimal to binaries using the place values. But if you want to know further like number conversion from any format, from hexadecimal to decimal or any hexadecimal to octal, then let me know in the comment section. Alright, so here let's go into our topic. So in the computer's memory, here the number 7 is going to be stored in the binary format, that is nothing but your 0 1 1 1, which is the binary equivalent of your number 7. Alright, so, and of course what you have to know is, in the computer's memory, inside the computer's memory, how it is going to be stored, right? So you know that computer memory is nothing but a long tape of bytes, right? Let me draw like this. Here let me draw like this. Okay, so I will put here 3 dots here, and then here also another 3 dots, right? Okay, alright. So here also another three dots are there, right? So I have taken 3 dots here, and it is open. I have kept it as open, and here also one tail is there, which here also I have put 3 dots, which I have kept as open. Why? Because it is a long tape of bytes. It is a never-ending bytes, right? So there are many more bytes apart from this. That is the reason why I kept this n as open, right? So these 3 dots indicates that there are many more apart from these bytes which I have taken, right? So here also in the beginning also there are 3 dots, yeah, right? So here in this one space, it is nothing but it is occupying what? It is occupying 1 byte, right? So it is occupying 1 byte. So 1 byte is nothing but it is equivalent to what? 8 bits, right? 1 byte is equivalent to 8 bits. Alright, so how it will be stored inside the computer's memory? So in the computer's memory, it will be stored in as 0 1 1 1. Here it will be stored like this, right? So we will draw the larger view of this. Okay, we will draw the larger view of this. This number 7, how much space it will occupy in the memory, that we should know first, right? So how much space it will occupy in the memory, that we should know first. So it depends on the data type that you are using, right? So for integer, for our computer, right, nowadays it is occupying 4 bytes in the memory, right? It depends on the data type that you are using. So for integer data type, it will occupy 4 bytes. But keep in mind that it is machine dependent, right? For traditional computers, it was 2 bytes, but for our but now uh, uh, for our latest computers, it is occupying 4 bytes, right? So our integer is occupying 4 bytes in the memory. That means that means here it is 1 byte, here it is another 1 byte. So that means 1, 2, 3, 4. It will occupy these 4 bytes in the memory, and 7 will be stored here. But how? As we have said earlier, we cannot store 7 as it is inside the memory, right? But how it is going to be stored? It is going to be stored in the binary format. But how? Let us view this in a larger view, right? Let us view this in a larger format. So here, let's suppose uh, this is 1, 2, 3, 4, right? So this is nothing but 1 byte. 1 byte is equivalent to how much? 1 byte is equivalent to 8 bits, right? So here in this, there will be 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. There will be 8 zeros here. And again, how many zeros it will occupy here? 1, 2, 3, 4, 5, 6, 7, 8. Again, 1, 2, 3, 4, 5, 6, 7, 8. And again, 1, 2, 3, 4. Then what is the decimal, what is the binary equivalent of the number 7? Is nothing but 0, 1, 1, right? So at the end, 0, 1, 1, 1 will be stored. So here we can see that inside the computer's memory, in a larger view, the number 7 will be stored like this. This is nothing but 1 byte. This is nothing but 1 byte. So here it is occupying 8 zeros. Why? Because we have 8 bits. Okay, so that is the reason why here the number of zeros is 8. Okay, this is the way your number 7 is going to be stored inside the computer's memory, right? So after knowing this, we will go to our previous explanation of variable, right? So the previous explanation of the variable, what we have explained is nothing but int a is equal to 7, right? So int a is equal to 7. What if I want to store in place of 7 the number 9, right? In that scenario, this number 7 will get overridden and then number 9 will get stored, right? And again, a scenario came in wherein I want to store the number 30 in this variable so called a, right? So here I will store 30 here, but the number which was previously stored, that is nothing but your 9, will get overwritten. That means there will be no more 9, no more 7, only 30 will be there, right? So from this we can conclude that there is a drawback of variable, right? There is a drawback of variable declaration using variable, right? What is it? It is nothing but using a variable we can store only one value, right? So if why we are learning data structures, why we are learning programming, why there is data science, we are into the era of data science, right? Data is everything. Data plays very important role now in this new era, right? So that means we do not want to store only one value. We want to store many values, right? So here comes the scenario that we want to store 30 values, but but under one single variable name. Alright, so you may be telling, ma'am, we can take another variable int b, we may take another variable like int b is equal to 9, and again another variable called as int another variable, let me write it here somewhere, can you see? Okay, another variable called as int c is equal to 7. Yeah, we can do it, of course we can do it, right? Of course we can do it. But what if I want to store 70 values? In that scenario, you are going to take what? 70 new variables, different variables, right? Because under a single variable name, you are allowed to store only one value, right? So in that scenario, you are going to take 7 variables, which is not at all good, right? So now this for this scenario came a new data structure called as an array, right? This is here array came into picture. So what does array do? Array, under one single variable name, we can store many values at the same time, right? At the same time, meaning, let me rough little bit of this, just a minute. Let me rough this here. Okay, let me rough all of this here. All right, let me take this pen. Okay. All right, so I think you can see the areas here. Okay, now you can see. Okay, so meaning array here, under a single variable name, we are able to store as many values as you want. Let us take 50 as an example, right? So that means here this 50 is nothing but your size of the array, right? This 50 is nothing but the size of the array, and this a is nothing but what? It is nothing but name of the array. It is nothing but the name of the array, right? So what we can come up from here, we can come up with a definition of array, right? So what is an array? Okay, before that we have to understand one more logic, one more concept, that is, say for example, from this we can come up with a syntax. So we should know the syntax, right? So we should know the syntax of array, how to write an array, right? How to declare an array. This is called as array declaration, right? So how do we declare an array? It is nothing but first one is nothing but data type that you want, the type of the array, data type, and then name of the array, then inside the bracket you should write the size of the array, right? So here, from here, let us take for example 50 is huge, so I don't have much space to write here, so let us take the size as 5, int a of 5, right? So that means the size of our array a is 5. That means what? We can store 5 values. That means we can store 1, 2, 3, 4, 7, etc. Any value of your choice, right? But keep in mind that you cannot store R, 3, 5, 7 E. This is valid, right? But this is not valid. Why? Because array, inside the array we can store data of only similar data types, right? The data items that you are storing should be same. We cannot store different data items under a single array, right? So from these, what you can come up with a definition of the array, right? So array is nothing but a collection of what? A collection of data items of what? Of similar data types, right? Similar type. That is the definition of your array, right? So, and one more thing is, this size should, you should take the size of your array as the constant value, right? That means, for example, if we write int a and we left this as blank, this is not valid. This will give you what? Compile time error. This will give you compile time error, right? Because we cannot leave the size as blank, right? And one more thing is, like if you write int end comma a of end, like that, this is also not valid. Because why? Because only constant values are allowed to be written inside the size, inside the size of the array, right? Of course, there may be some there may be another case, like wherein you can use macros, right? You can use macros. So macros are nothing but uh, you have to write the macros before the main function and after the header files, like using hash define n, you write 50. Then in that case you can use int a n here, right? So by macros, you know that it is nothing but a constant. It will remain, the end, the value of n will remain 50 throughout your program, right? So here this is another constant. In one way or the other, we can say this is also a constant, right? So that means we can use macros, but you cannot use simple and a until and unless it is a macros. Okay, so that means inside the size you are allowed to write only the constant value, right? So this is nothing but what? This is nothing but array declaration. So let's if we have learned about array declaration, now let us see the definition of the array. Okay, let me rough this once again. I don't have too much of space here. Let me rough this once again. Let me rough all of this once again. Okay, alright. So here we know how to declare an array, but how to initialize an array? Definition, array definition. So there are two ways of initializing an array. One is known as compile time initialization. One is known as compile time initialization. One is known as compile time initialization, and or else it is also called as what? It is called as what? Static initialization. It is also called as static initialization. Static initialization. Alright. So second one is nothing but runtime initialization. Runtime initialization. Runtime initialization. Okay. And writing is too bad, but okay. It's okay. Okay. So what is compile time initialization? Compile time initialization, it is also called as what? Static initialization. Meaning during the declaration of the array only, you are going to declare the values of the values, means the elements of your choice, right? So that means here when you I think you can see this. So int a of 5, right? So here the type of the your array is nothing but your integer, right? So here the size is 5. That means you can take the values, the size, and the number of elements, that is 5. You can take 5 elements, but not more than this. If you take 6 elements, what will happen? It will give you compile time error. Alright, so it will give you compile time error. So you cannot take the number of elements more than the size that you have declared. Alright, so meaning here you can take the values that is of same type, of course, and the data type is integer, meaning you can take only integer values here. Here that is -1 is also an integer, 0 is also an integer, 3 is also an integer, 5 you can take any number, 6, okay, you can take any number of your choice. And of course somebody might be thinking, what if we write only -1 and 0 and 1, and what if the size of our what if the size of our array is 5? All right, so so I mean we have declared here the size. The size here is what? The size here is 5. But what if we have initialized only -1 and 0? Will this give us an error? No, of course not. This is not going to give us an error. Alright, so what will happen is nothing but the remaining values will be assigned with zeros automatically, right? So the remaining values will be assigned with 0 if you initialize only 2 elements, and the size of the size of the array is 5, but you have given only 2 elements. Then the remaining 3 elements will be assigned with 0 automatically. Alright, so this is nothing but compile time initialization. So inside the memory, how it will be stored, let us see. So we know that the integer data type, how many bytes it occupies? It occupies 4 bytes in the memory. And also keep in mind that the addresses inside the memory are in the hexadecimal format, right? For simplicity purpose, we are explaining things in the decimal format, but you should always keep in mind that inside the computer's memory, these addresses are always in the hexadecimal format, meaning the hexadecimal formats are nothing but the numbers starting with 0 and x. This x can be small letter or capital letter, it doesn't matter, but the numbers starting with 0x and followed by 1, 2, c, etc. These numbers are nothing but the hexadecimal numbers, right? It should start with 0 and x. So but here if we explain 0x, 1, 2 like that, it will become even more complex, right, to understand. So in order to make it easier to understand, we took only in the decimal format for the simplicity purpose. Alright, so here inside the computer's memory, if the array is how the array is stored, we will see. Okay, so here as we have discussed earlier, memory is nothing but a long tape of bytes, right? Memory is nothing but a long tape of bytes, right? Long tape of bytes. So it is never ending, so we'll give 3 dots here, right? So let's say your address for this first byte is nothing but 1000, right? So of course next address is nothing but your 1001, and next address is nothing but your 1002, and then 1003, and so on. But how much byte your integer data type is occupying? It is nothing but 4 bytes. That means from 1000 to 1003 it is going to be occupied, right? For which value? For -1, right? For -1 it is going to for minus 1 here, it is going to occupy from here to here, right? So from here to here, the minus 1 value is going to be occupied. Let me rub this and let me write clearly. Okay, let me rub this and write this properly. Okay, here. Alright. Alright, so here, from here to here, which value is occupied? Let us write our array once again, int a of 5, and let's take any value, minus 1, 6, 7, 0, 1, 2, 3, 4, then let's take 5. Okay, so these are nothing but our elements inside our array, right? So here, this 1000 to 1003, these are nothing but 4 bytes. It will be occupied by the first element, which is nothing but minus 1. Why? Because integer is occupying 4 bytes in the memory, right? So the next bytes, 1, 2, 3, 4, it will be occupied by which element? The next element, which is nothing but 6, right? So next 4, 1, 2, 3, 4. Next 4 will be occupied by which element? 7. And then next 4 will be occupied by which element? 0. And next 4 will be occupied by which element? 5, right? So here we can view this. We can view this in this manner. From this, we can view our array in this manner, right? So how we can view it is like your elements, minus 1, then 6, then 7, then 0, then your number 5, right? So the starting address is nothing but your 1000. That means 1000 becomes the address of this minus 1. But from 1000 to 1003, it's been occupied. So it cannot be used by any other variables or any other elements, right? So that means from where it will start, from 1000 to 1003, it is occupied. It is obvious that it will start from 1004. The next byte is nothing but 1004. The address of the next byte is nothing but 1004. That is why we have written 1004 here, right? Because why? The data type of this array A is nothing but integer. That is the reason why we have it is occupying 4 bytes in the memory. So from 1004 to 1007 will be occupied by this number 6. Then what is the next address? It is nothing but 1008. Likewise 1012, next is 1016. The difference of 4, right? So this is nothing but how the array's indexing takes place, right? So the name of your array is nothing but A here, right? So array indexing starts from 0, meaning 0, 1, 2, 3, 4, right? So it is not a compulsion that array indexing should always start from 0. Somewhere it is starting from 1 as well, but generally it should start from 0, right? So here it is starting from 0 to 1, 2, 3, 4, that is n minus 1, by n meaning the size of the array, right? So how can we find how the arrays can be accessed? How the arrays can be accessed? Arrays can be accessed this way, by using the index, right? Arrays can be accessed by using the index. Index meaning here 0, 1, 2, 3, 4, right? So a of 0 is nothing but your value stored inside is minus 1. So a of 0 is minus 1, a of 1 is nothing but what? A of 1 is nothing but your number 6, a of 2 is nothing but your number 7, a of 3 is nothing but your number 0, and a of 4 is nothing but your number 5. Alright, so this is how we access the arrays, elements of the arrays, right? But how do we find the address of the array? The addresses are nothing but 1000, 1004, 1008, 1012, 1016, right? So how can we find the address? How can we find the address of the array, right? So we have a formula. What is the formula? Formula is nothing but base plus I into size of the data type, size of the data type, size of the data type. Using this formula, we can find out the address of the array, right? Address of the array. So this I is nothing but the index. Okay, let's see then when I is equal to 2, when I is equal to 2, so what is the address? Let us calculate using this formula. And of course we can see that when the index I is 2, of course our answer should come 1008, right? So let us calculate and see whether we get 1008 using this formula. Okay, so base address, this base address, okay, base address, right? So this base address is nothing but your starting address, right? So what is your starting address? Starting address is nothing but your 1000, right? So 1000, so base address here is 1000 plus, right? So which I have taken, I is nothing but 2 here, so I should write 2 here, asterisk the size of the data type. So what is the size of the data type? The size of the data type is nothing but 4 here, right? So following the BODMAS rule, we have to do the multiplication first, right? So that means 1000 plus 42 is nothing but 8. That is nothing but 1008. Yeah, we got our answer. At index 2, our address is nothing but 1008. So if in any competitive exam or any college exam, or if any question comes, if given an index and you are asked to calculate its address, then you have to use this formula. Do not forget, it's easy to remember. So if it easy to remember, so don't remember anything, don't memorize anything. It is easy, just look at it. Base address plus I into size of the data type. It is obvious that you should come up, you should click into your mind that that 1008 should come as an answer. Why? Because the data type is integer and it is, the difference should be 4. Then from that only you can come up with the formula by yourself, right? So do not memorize anything. So this is nothing but what? This is nothing but compile time declaration, compile time initialization. And one more thing is there, which is nothing but runtime initialization. Let's rough this one, clean it up. Let's clean this up little bit. Okay. All right. Okay, so we have seen what is compile time initialization. Let's see what is runtime initialization. By runtime, we know that the input that we are going to use is going to be taken from the keyboard, right? If the runtime, during the runtime, right? So if input is going to be given or taken from the keyboard, that means what comes in our mind? Scanf function, right? Yeah, you're right. Scanf function comes in your mind, right? If we are going to take input from the user, that means from the keyboard, then we have a function called as the scanf function, which is used for taking input from the user using the keyboard, right? So how we are going to write? And of course we are not going to input a single value for array, right? So we are going to input many values from the keyboard. That means we are going to use what? Loop. Using the loop and using the scanf function, we are going to initialize the array, and that type of the initialization is called as runtime initialization. Alright, so how do we initialize the arrays, the runtime? So let's see. Okay, so we have to take a for loop, right? So int a of 5, comma, we have to take one variable called as I, and then we will write for Let's take for loop, because for is my favorite loop. So for loop, I'll take for I is equal to 0. Why 0? As the indexing starts from 0, then we should take the starting value as 0. So I should be less than what? I should be less than n, right? N, and n, then I plus plus, right? So that, then after that we will use scanf function. Scanf function percentage d, then we have to write a of I, right? So if any one of you wants me to make a video on the very basics, the fundamentals of C, how what is scanf, what is printf, what is for loop, why differences between the for loop, while loop, do while loop, etc., then do write in the comment section. All right. So here how this will be stored. So here when a of 0, when you click a of 0, that means at a of 0 your elements will be inserted. So how many times the not n, it should be a less than what? A less than 4, right? A less than 4. Okay, a less than equal to, okay, it will be something like this, right? So it will be something like this. This is index 0, 1, 2, 3, and then 4, right? So less than equal to 4. So less than equal to 4, not n. Okay, I have not taken the value of n, so we will not take n. So it should be less than equal to 4. 4, why 4? Means n minus 1. N minus 1 is nothing. If n is the size, then size minus 1 means the size of our array is nothing but 5. That is 5 minus 1 is nothing but 4. That is the reason why I have written here 4. So our loop will go from 0 to 4. Our loop is going to go from 0 to 4. That is a of 0, a of 1, a of 2, a of 3, and a of 4. And you can enter any value of your choice using your keyboard. This is nothing but your runtime initialization of array, right? So we know what is array, what is how do we declare an array, what is the how do we what are the different kinds of array initialization, and then and how it is stored inside the memory, etc., right? So so what is the drawback of array? So drawback of array is nothing but wastage of space is one drawback of array, meaning here we initially we have to declare the size of the array, as we cannot leave this one as blank because it will give you a compile time error, right? So it is going to give you a compile time error. That is the reason why we have to specify some constant value here, right? So if we have to specify the constant value, so what if we want the value greater than the size of the array? And there we cannot do so. Of course, some dynamic array and all is there. Another concept is there, but as of now, that is a drawback. It means it will give you a compile time error, right? So that is one drawback of array. And another drawback is if if we declare the size of array as a of 1,000, right? But we have used only 5 spaces, a of only 5 spaces, 5 elements, 1 2 3 4 5, right? So that means the remaining 95 spaces are being wasted, right? So the another drawback of array is nothing but the wastage of space, right? Wastage of space is another drawback of an array, right? So you may ask one more question, right? Ma'am, you have told like if we initialize only 2 elements and the size of element is 5, the remaining elements will be appended with will be assigned with 0 automatically. What if we use character array? In that case, if we use the character array, in that case the remaining elements will be assigned with the null character, right? The remaining values will be assigned with null character, right? So So let's recall once again what we have studied. We have defined, we have got a definition of array. Finally, we have got the definition of array. So what is an array? It is nothing but the collection of data items of similar data type, right? If it is int, you can take only integer elements. If it is character, you can take only character elements, and so on and so forth, right? So another thing we should keep in mind is it is the 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 elements are stored in the continuous manner, meaning the elements of the array should be stored in the continuous manner, meaning one after another, right? You cannot store the elements of the array randomly inside the memory. It should be continuous or contiguous, that is one after another, right? That is one more drawback of array, right? And then random access is possible in array. This is one advantages, because it takes only big of 1. Okay, it takes the time complexity of accessing any elements inside the array is nothing but a constant big of 1. So this is nothing but an advantages of array, right? So these are all about array, and there are different types of the array, of course, and we are discussing about one dimensional array. There are three types of array, or various types of array, you can say. There are the types of the arrays are one dimensional is one type, two dimensional, and multi-dimensional array, right? So there are three types of the array. One is one dimensional, second one is two dimensional, and third one is multi-dimensional array. And in our today's lecture, we are discussing all about one dimensional array. One dimension in the sense there is only x-axis, right? There is only x-axis. I think you can see. Let me drag this little bit up. Okay, so one dimension means it is going only in one direction. One dimension means it is going only in one direction, that is only in the x-axis, right? So meaning your values are going to be stored here. Your numbers are going to be stored here, right? So that means we have what? We have one row. We have what? One row. We have one row, but here how many columns are there? We don't know. It depends on the size of the array, right? So one row and then multiple columns, right? So this is one row, multiple columns is called as one dimensional array, in other words, right? So 1D means one dimension. We can see only x-axis here. So one row but multiple columns. The number of the columns depends on the size of your array, right? So these are all about the arrays. So if you have any doubt, comment in the comment box. So let's stop here for today, and bye for today. Let's meet you. Let's meet in the next video. Thank you.